Welcome to our topic number 4, namely trigonometric addition formulae in pure mathematics 3, and you will get this on page 70. And this is quite an interesting topic because it's a topic of proving or showing this is equals to that. And we have so much that we know about trigonometry. We know some basic rules that sine of any angle theta is opposite over hypotenuse. Generally, we can talk about the SOHCAHTOA. We know what the SOHCAHTOA means. We also know that the sine squared theta plus the cos squared theta is 1. We know the sine of theta over the cosine of theta will always give us the tangent of theta. Okay, we have the cosec, the sec, and the cotangent. We also know about the inverses, arcsine, arccos, and arctan. But for now, we need to use basically what we know to prove some other trigonometric formulae, and we are calling them trigonometric addition formulae. And before we go far, I would want to explain what is in this diagram. In this diagram, you will see that angle BAC is alpha, and angle CAE is angle beta. You can see there. And you can also see that the line AE is 1 unit, either centimeters, meters, or whatever it is. You can also see that we have line AB, which is perpendicular to BC and also perpendicular to DE, passing through F. You can see the 90 degrees, which shows or signifies perpendicularity. You can also see that line FC is perpendicular to FE. You will also see that EC is perpendicular to AC. You can also see the symbol of 90 degrees telling you that it is perpendicular. And we are expected to use the diagram together with known properties of sine and cosine to prove the following identities. In example 1, we will be able to show only property A, which says A sine alpha plus beta is exactly equals to sine alpha cos beta plus cos alpha sine beta. And we will go through several steps explaining and explained in this diagram to prove what we have. I will go very slowly because this is a bit complicated, and it's going to demand that we concentrate so highly into this particular explanation. So I'm calling upon everybody to seriously concentrate on what we are going to learn today. And to begin with, if I may focus on triangle ACE, and I want you to see triangle ACE, which is right angle at point C. If we focus on that, we will highlight the angle beta and say the cosine of beta, according to the natural law which we know, is going to be given by the adjacent side, which is AC, is going to be AC over the hypotenuse, which is AE. It follows that the cosine of beta is AC over, you will see AE is equals to 1, or rather the hypotenuse of that triangle is equals to 1. So what are we saying? What we are saying is that if we cross multiply here, we are saying that AC is equal to the cosine of beta. Underline that. the AC, that line is equals to the cosine of beta. We can even name it here. Let's start there. The cos of beta, that is AC. Again, if we concentrate on triangle ACF, if we do not triangle but the angle ACF is actually alpha due to the fact that the line AB is parallel to FC, and this is a transversal, and angle BAC alternates with angle FCA, so that angle is alpha. It goes without saying that if this is the whole of angle ECA was 90, so this angle is 90 minus alpha, that angle. And because there is a 90 degrees here, it's a right angle within triangle EFC, there is a right angle there. It is also important to note that if this angle is 90 minus alpha, then 90 minus alpha plus a certain angle here should give you 90, because already this is 90. Remember, the angle sum of a triangle is 180. So this angle there plus this angle here should give you 90 degrees, because we already have 90 here. And if this is 90 minus alpha, so that angle itself is alpha. That is alpha degrees, such that alpha plus 90 minus alpha, you will get 90 degrees. In triangle ACE, we can also highlight something to do with the sine of beta. And the sine of beta is going to be using triangle, this is using triangle ACE. And again, we are also going to use triangle ACE. And we are saying the sine of beta is, of course, opposite over hypotenuse. And what is the opposite? Opposite is CE over the hypotenuse, which we said is AE, of course, over 1. And that gives us now the sine of beta is, if we can just repeat this step, the sine of beta, according to what we have known it, is CE over 1. And if we cross multiply, we are going to make CE the subject of the formula here, which is simply sine beta times 1. Underline that. We can even give it a name. We can even give that line a name and call it sine beta, that line. Having said that, we will further talk about, if we focus on the triangle FEC now, triangle FEC. If we focus on triangle FEC, then we are going to say that the cosine of alpha is adjacent over hypotenuse, using triangle FEC, that the cosine of alpha is given by the adjacent, which is EF, and the adjacent is FE, over the hypotenuse, which is already EC, and this gives us the cosine of alpha is FE over EC itself sine beta. You can see the hypotenuse of that triangle happens to be sine beta. And therefore, this gives us, if we make FE the subject of the formula, it's going to be cosine alpha sine beta. Underline that. FE is cosine alpha sine beta. Again, if we focus on triangle FEC again. Triangle FEC again. Now we will talk about the sine of alpha. The sine of the same angle alpha is of course opposite, which is FC, this alpha, opposite which is FC over the hypotenuse, FC over the hypotenuse which is EC. This gives us the sine of alpha is FC over EC, which is sine beta. Again, you can see EC. So if we happen now to make FC the subject of the formula, FC becomes sine alpha sine beta if you cross multiply. Underline that. Again, we can already see that in triangle ABC now, if we focus on triangle ABC, in triangle ABC, using triangle ABC, we can already see that the sine of alpha, this alpha, the sine of alpha is opposite BC over the hypotenuse AC. Sine alpha is equals to BC over the hypotenuse AC. And remember, in our first explanation, we already know what our AC is. So if we can further do this, that means the sine of alpha is given by the BC, which is this line, over AC, which you can already see is cosine B. You can also see it here. AC is cosine B. It is explained in the very first line. That means AC is cos B, so cos beta. So if we happen to make BC the subject of the formula, then you're going to say BC is equals to sine alpha cos beta. Underline that. Finally, in triangle ABC again, triangle ABC, we are going to talk about the cosine of alpha. The cosine of alpha, which is adjacent, now AB, all over the hypotenuse, and the hypotenuse we have known it to be AC, which gives us the cosine of alpha, giving us AB over the cosine of beta, because we are talking about over AC, which is still the cosine of beta. If we happen to make AB the subject of the formula here, we're going to say AB is equals to cos alpha cos beta after cross multiplying. Underline that. So, having highlighted all that, now we need to prove this identity, meaning that using triangle, and this is now our point, or the point when we want to prove this, because we have all these details. And you can see using triangle ADB, using triangle, let's see, triangle ADE rather, ADE, using triangle ADE, using triangle ADE, what do we have? We can already see that if we use triangle ADE, we need to combine the two angles, and this, the whole of this angle is alpha plus beta, and we can go ahead and talk about the sine of both angles put together, alpha plus beta, again given by the opposite, which is DE, the opposite, which is DE, over the hypotenuse AE, over the hypotenuse AE, And you can see already DE is what you're looking for, but AE is already 1. You can see AE is 1. So we are simply saying that DE is equals to 1 because AE is 1. You can see from the diagram, times the sine of alpha plus beta. This is very important, at least up to that level. Our line DE gives us the sine of alpha plus beta. Now, if you talk about, again using triangle, the same triangle, using triangle ADE, you can now talk about the cosine of alpha plus beta, the whole angle again, which is adjacent of a hypotenuse. The cosine of alpha plus beta is going to be the adjacent AD all over the hypotenuse, which is AE. The hypotenuse of triangle ADE still remains AE, and its measurement is simply 1. So this being 1, if we cross multiply again, we can make AD the subject of the formula. AD becomes 1 times the cosine of alpha plus beta. So what are we simply talking about? Now, if we are interested in expressing DE as a line, we can already see that DE is DF plus FE. If we want to express DE as a line, we are going to say DE is equals to DF plus FE. All right. At that point, I would want to highlight what our DF is. What is our DF? Our DF, I don't know whether we have expressed it somewhere. Our DF becomes, because we can see FE. Where is FE? FE is cos alpha sine beta. Cos alpha sine beta. That is FE. But if you would want to talk about DF, you cannot talk about you can also talk about DF in terms of BC, because this is a rectangle and DF is equals to BC. So BC is very much equals to DF. Therefore, DE is equals to DF plus FE, meaning that this is BC plus FE. But in our narration, what is our BC? Our BC is sine alpha cos beta plus FE is cos alpha sine beta. Now, I want us to go back to what we are supposed to prove. We had talked about DE somewhere. This is our DE. That is very crucial. So instead of writing DE now, then we can say DE in terms of sine alpha plus beta. Then we are going to have sine alpha plus beta is exactly equals to sine alpha cos beta plus cos alpha sine beta. And that is exactly what you're supposed to prove as per our requirement in example 1, part A. We are supposed to show that sine alpha plus beta is equals to sine alpha cos beta, which is still here, sine alpha cos beta plus cos alpha sin beta plus cos alpha sin beta. That is quite quite an amount of work, but I expect that you can follow. Without this narration, there is no way you can do this. And this is a very important diagram in explaining all.